Hey guys, this is Carl, and this is week 6, problem number 6, and so we'll go ahead and jump in. In a large business statistics class, the professor has each person select stocks by throwing 18 darts of a business newspaper. Then they check to see whether a stock of their picks rose up or down, report the proportion of successes. As a lesson, the professor selected pages of the newspaper for which exactly half the publicly traded stocks went up and half went down. The professor then makes a histogram of the reported proportions. Completes part A through D. Part A. What shape do you expect his histogram to be? His or her histogram to be, and why? Well, it's symmetrical because the probabilities are success and failure are equal. Why? Well, remember in this key sentence, um, half went up and half went down. So essentially, it's almost like a coin. 50% chance or probability of heads, 50% probability of tails. So that's a symmetrical distribution. So part B, where do you expect the histogram to be centered? Obviously, it's centered towards point 0.5 because point 0.5 is the threshold of success or failure based on the way it's been described. It's very similar to a coin flip. Part C, how much variability would you expect among these proportions? Now remember that variability is the standard deviation because you want to know how much it deviates. How much deviation there is, that's in the key in the word itself, is how much variance is there, how much deviation is there from the center. So in the simplest of terms. So our equation is the square root of p times q divided by n. So remember, p is equal to our probability, and q, remember right here, is equal to 1 minus p. So what is our p? Well, our p is 0.5 because there is a 50% probability of success or failure based on the construct of this question. And q, similarly, just because it's a little bit of an easier example, is 1 minus p, or 1 minus 0.5. So as you can see down here, what is n? N is our sample size, which is up here, 18. So for the equation that we've entered, you can see here the square root of 0.5 times 0.5 divided by 18, and that's where we get 0.117851, or if you know how to do this in Excel, you go to Format, and you can kind of trim this down a little bit in terms of the number. 0.12, make it a little easier to digest. 0.12 is the standard deviation. So, part D, explain why a normal model should not be used. Well, the success-failure condition says that the sample size must be big enough so that both the number of successes and the number of failures are expected to be at least 10. So that's really kind of the threshold that we're looking at in the success-failure condition. So because our sample size is 18, and 18 times 0.5 is 9, which is less than 10, the condition is not met. So that's, and the condition is not met, therefore the normal model is not, should not be used rather. So we hope that this helps your understanding, and you just let us know if you have any questions along the way. Thanks so much. Bye.